Hello friends, welcome to video lecture on kinematics of machinery. In the today's session, we'll learn about the pantograph. So pantograph is a mechanism consisting of lower pairs used to produce path on an enlarged or a reduced scale exactly similar to that one traced by a point on the linkage. So this figure shows the diagram of the pantograph in which the four links AB, BC and this one CD are arranged in a such way that the parallelogram A, B, C, D is formed, in which AB equals to CD and CB equals to this one DA. The link CD is extended to point O and the link CB is extended to point E in a such way that OAE becomes a straight line. For all the relative position of the links, the triangle OD and A and OCE are similar and the points OAE are in one straight line. It may be proved that point E traces out the same path as described by point A. This will clear to you with the help of this animation. So as per our previous discussion, if you look to us here, whatever the path traced by this one E point is same as that of the A point. So here if you just see, we can get the enlarged scale of the same. So whatever the part traced by this one and this one is similar one, but we can get here enlarged scale of the same. Now ABCD is the initial assumed position. A, B, C, D is the initial position. Also OAE is the initial straight line. In triangles ODA and this one OCE, we can just say the angle here angle AOD equals to angle EOC and angle ODA equals to angle OCE. So as this one DA is parallel with the CE, we can just write this one. Now therefore the triangles are similar and we can write this in this way: OD divided by OC equals to OA divided by OE and DA divided by CE. Let point this one O be a fix and the links are moved to other position, so that here the A moves towards the next position, that is A dash, B moves towards the next position, here is the initial position of the B, okay, that will move towards the next position, that is B dash, C will move towards the next one, C dash, and E will move towards the next position, that is E dash. And similarly if the other points are there, then that also moves in a similar way. Now in this case, if you just see here, AD must be equals to A dash D dash. At the same time, you just see here BC is nothing but the C dash D dash. Similarly, next one C dash B dash is nothing but the CB. In this way, I can get the relation. Therefore, this one A dash, B dash, C dash, and this one D dash is again a parallelogram. So here in this case also we can just prove that whatever the lengths here, ratio of the lengths we can get here for the displaced position and the original position are the same one. Now let us prove that the triangles O, D dash and A dash and O, C dash, E dash are similar. So from this one, we can just say OD dash equals to OC dash equals to OD by OC equals to DA divided by this one CE. For this, we can just write D dash A dash equals to C dash E dash. Also, the angle O D dash A dash equals to angle O C dash E dash. So in this case, we can just say A dash D dash is parallel with this one, C dash B dash or C dash E dash. As this one, A dash, B dash, C dash and D dash is the parallelogram. Hence the triangle O D dash A dash and O C dash E dash are similar. So in this case we can write angle A dash O D dash must be equals to angle E dash O C dash. Hence O A dash and E dash lie on a straight line. Also from this relation number 1, we can write in this way: OA by OE must be equals to OD by OC. So this is the case where the initial position of this all the links in front of you, when that displays at another position, then we can just say here OD dash, initial position is here OD by OC. This you can write in this way: OD dash divided by OC dash. Similarly, O A dash divided by O A dash. In earlier case, we have written OA by OE. Now the above result shows that the ratio of the distances of A and E from the fixed point remains same as the links are moved. This is true for all the position of the links. Hence, point E traces out the same path as described by the point A. This will more clear to you here. Okay, so whatever the path traced by this one E point, okay, let us assume that here is the A point, here is the E point. Okay, so here the same path is traced by the point E in the enlarged scale. Okay, hence if the O is fixed to the frame of a machine by means of turning pair and A is attached to a point in the machine which has rectilinear motion, then E will trace out exactly similar path but to a different scale. Similarly, if E is constrained to move in a straight line, then A will trace out the similar path. Okay, so pantograph is used to reproduce the drawings to a different scale, that is on enlarge or reduce scale. Okay, it is also used to guide the cutting tools. Thank you. I hope in the today's lecture the theory discussed about the pantograph cleared you. Thank you.